Okay guys, the human eye. My name is Mr. Mpepu. Today's date 26 April 2024, Friday, and the time there 32 minutes past 11. With that being said guys, Sanbonani, Dumelani, Avsheni, hello, Nda guys, I welcome you to my session Learning Life Science with Mr. Mpepu, Monday to Friday. As you can see, tomorrow it's our Freedom Day. We are celebrating that Freedom Day. Those who are new here, feel free to subscribe, feel free to comment, feel free to like, guys. Feel free to share these videos so that we can reach more learners out there, right? Today we'll be dealing with revisions and the end of topic exercises under human eye. Next week we'll be starting with our human ear. We are done. Tomorrow I'm not going to post any video so that you'll be able to revise all these videos and be able to revise the work that we did during this week, right? So thank you for being here, guys. Those who are subscribing, thank you. And then those who are returning students, those who are following me every day, those who are following me every day, guys, I really like to appreciate you. Let's move together. Shosholoza, right? Happy Freedom Day in advance. We are moving on. We are under week 6. Week 6, we're still dealing with responding to the environment by humans, studying our human eye, right? We are done with our human eye. We did the structure. We had our plan Monday, Tuesday, Wednesday, Thursday, Friday, and today we are here at Friday, right? We did our structure and functioning. We did our accommodation and popular mechanism. We did question and answer. Thursday, we did what we call the visual defects, right? Those long-sightedness, short-sightedness, astigmatism, and another one, cataracts, right? So you'll agree with me that we can move on now. Next week we are here, we'll be dealing with human ear, right? At this moment, you know what is happening with our brain, you know what is happening with our spinal cord, you know what is happening with our neurons, our nerves, you know what is happening with our receptor organ named a human eye. You'll agree with me, right? So we can move on. Caps, we are done here. You'll agree with me, right? We are done here. This one we didn't do it, right? But we're supposed to dissect an eye of a sheep or a pig. Where do we find it? We go and buy it. Then, here they want money that we don't have. So we are just going to use our imagination. We did our imagination. We came up with many different types of eyes. If you've missed that, go back and watch, right? So today we are done here, right? We did introduction, human nervous system. If you still remember, let's do this together. If you still remember, we did introduction, we did nervous system, and I told you that our human body use nervous system and our endocrine system, right? Next week we'll be dealing with endocrine system. This week we are done with nervous system, right? Mind you, yesterday we also did this, that nervous system is divided into two parts: central nervous system this side and peripheral nervous system this side. This one divided into brain and a spinal cord, right? We did it. Where is it? We did it, brain and the spinal cord, right? We did the structure, and then we said that they are protected by meninges, right? We did the structure. We also came to the brain, and we learned that in our brain we have a part called cerebrum. We have the part called cerebellum. We also have the part called corpus callosum. We also have the part called medulla oblongata. Mr. Mpepu, can you draw that? Can you sketch whatever you're talking about there fast? This will be my sketch here, right? Then if I'm sketching this, this will be cerebrum, controlling all voluntary muscles. Cerebellum, coordinating all voluntary muscles. Our spinal cord, transmitting our nerves from our peripheral what we call peripheral system to our brain. We also have medulla oblongata there, controlling all our involuntary muscles, right? Our breathing, our heartbeat and everything, right? We also have hypothalamus there, the place for determining or to detect hunger and thirst and what, right? We also have a pituitary gland there, and then we have cerebrum there. You'll understand with me, right? With a spinal cord, we talked about this, that you'll need to see that spider, that's butterfly there, and then this butterfly here we also have surrounded by something, and then we also have the other what we call here the neuron entering our spinal cord, and we also have the neuron leaving our spinal cord under the vitreous humor, dorsal root, sensory neuron, motor neuron, interneuron, white matter, gray matter. You did this, right? And then human response to the environment, we talked about the stimuli, or we have to have the stimuli. Yesterday or previous days we were talking about a light stimuli, right? From light stimuli we also did a what we call touch stimuli, when we were touching a fire, doing a reflex arc and reflex action. You'll agree with me, right? Then from there, you know that we need to do this to respond or to react to our stimuli and to coordinate various activity, right, with our human brain there. So you'll agree with me. Let's move, Mr. Mpepu. Peripheral nervous system, we did this, and then this will be this side here. Peripheral nervous system divided into two parts, a sensory neuron and a motor neuron. This motor neuron divided into two parts, what we call, another one going to the another side, to a somatic nervous system. This one going to our voluntary muscles, and we also have the other one that is going to involuntary muscles, that we said this one will be an autonomic nervous system. With this autonomic nervous system is dividing into two, sympathetic and parasympathetic. We did this, right? And then autonomic nervous system, we also did this, but we have to know the location and function, right? These are the motor neurons that they are outside of our centrally nervous system. When we talk about the this autonomic nervous system, we are talking about a peripheral nervous system, right? They also require us to learn the structure and the functioning of the nerve. Here we're talking about the neurons, which are the nerve cells that forms our brain and our spinal cord. We have three types of them: sensory neuron, interneuron, and motor neurons, right? And then we were also told us, or we were asked to determine or to differentiate all those three using a simple structure or simple diagram, right? We have our sensory neuron. We know that our sensory neuron, we are going to identify it by the body protruding outside of our axon. Our motor neuron, we are going to see the body there being covered by our dendrites. From our dendrites, our interneuron, we are going to see it in the body there being in the middle and not covered by our dendrites or our axon, right? Those are the three types of neurons that we did. And we also have to learn the functions of sensory and the motor neuron. We told you that this sensory motor neuron, they recept or they transmit an impulse that was recepted by our receptor. This receptor, they are going to convert this stimuli into an impulse, and then this impulse is going to be transmitted via the sensory neuron to the central nervous system. And then from the central nervous system, we see the axon of motor neuron transmitting this impulse here to our effector, right? And then this effector can be an organ, can be a what we call another one, can be an organ or can be a tissue, right? And then they said we have to have the structure here. We talked about it. We have our nucleus, and then we have our cell body. We were talking about them. We have our cytoplasm, right? We have myelin sheath. Let's talk about this myelin sheath. But this myelin sheath, it is the one that is insulating our axon there. And then what is the function of this? It is to transmit, or it is to increase the speed of impulse transmission, right? We did this. And then we also have our questions there that we were dealing with. What if our axon is not myelinated? What will happen if our axons are myelinated? So you know by then. And then we also have the axon, and then we also have the dendrites. When we have to differentiate these two, the dendrites, they transmit impulse from the dendrites impulse, they transmit impulse to our cell body, and then the axon transmit the impulse away of the cell body. So we moved on. We have to know, we were asked to learn about the simple reflex arc. With a simple reflex arc, you know that you'll have the receptor, you'll have the sensory neuron, you'll have the motor neuron, you'll have the interneuron or a connector neuron, you'll have the motor neuron, and you also have the effector. This here happening at a central nervous system, might be the brain or a spinal cord, and then this side here happening on our peripheral nervous system, can be sensory neuron or a motor neuron. These two also divided into two, one moving to our brain. We did this, right? We have our heart there being plugged with two motor neurons, right? One being sympathetic and one being parasympathetic. You'll agree with me, right? Then what is the simple reflex arc? Here we're talking about the knee jerk, or we talk about the reflex action where you are touching a hot surface, a reflex action, or the moment when you touch a cold surface. It cannot only be a hot surface, right? Every time you touch something, and then you can measure the temperature, you can feel the temperature, or you can feel that I'm holding something here, that impulses is being sent via the sensory neuron, from sensory neuron to our central nervous system to our interneuron or connector to our motor neuron to our effector. Right, we did a simple reflex arc there, and then we also talked about the synapses. We told you that these neurons of ours, they don't join together, right? They leave. You know that if we have a sensory neuron like this, it's going to end there at then axon terminals, and then these axon terminals, they have a synaptic knob, and then this synaptic knob, they are going to be closely or leaving a gap or a connection there with our dendrites. And then inside there we told you, or with this they remove a neurotransmitters, and then the dendrites said they're going to pick up these neurotransmitters, and then these neurotransmitters they are going to increase, or they are going to fork to cause an impulse to be also sent to another neuron there. The significance why is it important here, you know that it prevents it allows one direction of impulse, and also it prevents the overstimulating of our dendrites. That you'll agree with me, right? Then we did the significance of reflex action. Reflex action is the action that is brought upon by our reflex arc. So this reflex arc, this is an impulse, so this is the pathway of the impulse, and then the reaction that is going to be brought upon will be the reflex action. And then why is it important? So that we have this reflex action in place, right, where you can just react from something that is hot instantly. They are there to increase or to speed up the reaction time, right? We have to reaction time better than, or if compared when this impulse has to be sent to your brain, right? So the reflex action there, they are there so that our body can react fast, right? And then the function of simple reflex action, using an example, we did this, and then here we talked about the structure of a reflex arc, right? But the structure of reflex arc, using a diagram, we have the receptor. You know the receptor, we are going to have a sensory neuron. This sensory neuron is going to enter the central nervous system via the dorsal root of the spinal nerve, and then from the spinal nerve inside the spinal nerve there, or inside the brain, and then from there we are going to see our interneuron picking up the neurons from our sensory neuron to the motor neuron there, and then from the motor neuron they are going to leave our spinal cord via the ventral root of the spinal cord to the effector. You did this, and then you will have to define the reflex action and the reflex arc, right? Action brought upon by reflex arc. Reflex arc is the pathway that our impulse travels or follows. Then we did the disorders of central nervous system. If you still remember, we talked about Alzheimer's and we talked about multiple sclerosis. When we say this Alzheimer, it's when our nerve tissues are being degenerating, right? They are dying or they are decreasing in number, right? And then that end up, or that results in a impulse not being transmitted, or the impulse pathway or the reflex arc and not being completed, right? So if you don't have sensory neuron, it means that you won't have to, you can't sense the things so that they will be transported to your central nervous system. If you don't have interneuron, you won't have the message to be transported to the motor neuron or to the effector, and then without a motor neuron you won't have a reaction there. Alzheimer. And then multiple sclerosis, we also talk about this. These are the multiple scars where in our myelinated sheath there. So these myelinated sheath, they are being destroyed, and then we say this one is called by our autoimmune, right? Our autoimmune, our body is fighting against our body, and then there we see that our myelin sheath, they are being destroyed. And then how is this going to affect us? This is going to affect us because the impulse there will be not this will result in our impulse not being transmitted in a high speed, right, or in a more speed, whatever you want to put it like that, right? So that one will going to affect us. So you will have the reaction or everything, or the reflex arc can be completed, but your reaction time will be slowed because the impulse, they are taking time to reach the end or to reach their destination. From there we jumped to our receptors, saying that these receptors, these are the organs that are concentrated by our receptor cells, right? So these receptors here, we say the function of receptors, these are the neurons, and the effectors is responding to the environment. So we have the receptors, and then we are using these receptors so that we'll be able to respond to the environment, like our human eye, right? We use our human eye so that we can dodge things, so that we can move away, so that we can, you understand, all those things, whatever we are doing, we are trying to respond to the environment. But the body respond in environment in a different stimuli such as light. We talked about this one will be dealing with our human eye, sound, our human ear next week, right? And then touch, our skin, and then temperature, our skin, also pressure, our human ear next week, yeah. And then the pain, it will be our skin. So in our skin we have the receptors that they recept pain, right? Also in our eye there, in our eye we have receptors that recept light, right? And then in our ear we have a special light receptors that recept sound, right? Also with our tongues and what. We talked about this, right? That's when we jumped to our human eye. Then with our human eye, we did everything. We did the structure and the function of human eye, those pits and pieces of our human eye. At this moment, you know the structure of a human brain, you know the structure of human spinal cord, you know the structure of human eye, right? The receptor and the neurons there. You have a receptor that is recepting something, and then from there you learn all the thing that, oh, we'll have to have a receptor, and this receptor has to convert this stimulus into the impulse. This impulse is going to be passed via the optic nerve to our cerebrum. By this time, you know what is happening with our cerebrum. Our cerebrum, we are interpreting these senses. We are interpreting light, we are interpreting sound, we are interpreting taste, we are interpreting feeling, all those things, right? And then we learn about binocular vision, using two of your eyes to make up one images, right? And then the importance of this, you know that we have to measure the depth, we have to measure the distance, so that our measuring will be precise, right? We have to measure the object something, so that me seeing the object and say that this object is big or this object is small, using my binocular, my measurement, or my or whatever that I will be saying there, it will be accurate, right? Accurate, it will be accurate, it will be precise. Then we did accommodation and pupillary mechanism. When we say this accommodation, it's when your eye is moving, or your lens is shifting its position, so that it will accommodate something that is coming near to your eye. And we said while something is moving closer to your eyes, here's what is going to happen: your lens there are going to be big, and then this is brought upon our suspensory ligament being slackening or being loosening up. This brought upon by our ciliary muscle contracting, bringing down our ciliary body. So you know by this now, right? This is an accommodation. And then when something is moving away, hence they say it is an accommodating. Here your eyes have to have your muscle here, your ciliary muscles has to contract, so that the whatever is coming towards your eye, you can also be see it, right? Hence we said it's accommodating. And we talked about pupillary mechanism. Pupillary mechanism, we said that we have the opening there in front of our eyes, made out of a iris muscles, right? Those iris muscles having the circular muscles and a radial muscles. And then we talked about this, that the pupillary mechanism is the opening, or is the closing, or is the narrowing of this pupil here. When the pupil becoming small, the circular muscles, they are contracting, and the radial muscles, they are relaxing. And when our pupil is becoming big, our circular muscles there, they are relaxing, and our radial muscles there, they are contracting. You know that, right? And then it will result in our pupil there being constricting, becoming small. We can say it's a pupillary mechanism, pupillary reflex, or pupillary constricting. You know this, right? And then from there we learn about our visual defects yesterday. This one is still fresh. Yesterday we learned about our visual defects. We said that we have a short-sightedness where you can focus, or clearly you can see something that is near, but you cannot see something that is far. And then long-sightedness, you cannot see something, or you cannot clearly see. It's not like you cannot see, you can see, but your vision will be blurrier if something is closer, so you cannot see clearly. That's how we are going to explain this. In long-sighted, you are not going to see clearly something that is near, you are going to see clearly something that is further, right? Taking this information, or bringing the information of accommodation to these two, right? So you know that for something that we are bringing it closer, our accommodation has to do like this. So if our eyes is failing to do like this, we'll end up with long-sighted only. Understand, right? Hence here, for you to read something, you have to push it away. And then we also have astigmatism. This one is when we have our cornea and our lens being uneven, right? Whatever, it is uneven, right? It's not a fully shaped, or it's not a round or normally shaped, right? And then we have cataracts, and then these cataracts, these are the protein that are building up inside our lens there. We have our lens, and then we know that this lens is comprised of a water substance and a protein substance, right? These two here, they make up our lens there. And then this protein here, when they become clumpy, or when they come together, they form a protein, they form a cloud there, shutting down that lens, right? So we did this, we did this, we did this, we are done, we are done, we are done, we are done. Tomorrow or next week, we'll be dealing with a human ear. How do you hear? How are you hearing me now? Do you understand what is happening? The moment you say, by the end of the day, when you say, I heard someone saying this, what happened? We are going to learn it, right? Same as we learn our human eye, you learn that at the end of the day, for you to end up saying, I saw and I see, the word written elaboration. What is happening? You say something, sent to your eye, inside your eye, is going to be recepted by cones and rods there, and then these cones and rods, they are going to convert this stimuli into an impulse, and then that impulse is going to pass via optic nerve to your cerebrum. Inside your cerebrum, you are going to be interpreted this. If you have seen this before, you know that this is elaboration. But if you haven't seen this before, you are seeing this for the first time, there's a possibility of you not knowing what is this. Example, I'll write something again. Let me write those who are vendors, they've seen this, right? Those who are vendors, they see this. But if you are not a vendor person, this something you are seeing it for the first time, right? And this name here, it is read as Ngwana. So whatever you are seeing here, it's going to be passed to your brain, and then when it enters your brain, it's going to be interpreted as something that we don't know, right? The moment when you see something is being said, so these things are happening fast. You'll agree with me, it's happening fast. So what will happen if your optic nerve there, the myelin sheath, it is damaged, right? So now we can explain this thing. So you'll agree with me, guys. Let's move on. We are done. Today we'll be dealing with exercises, and that was the revision. The revision here is chapter 6. That was the revision. Revision here is chapter 6. Of our chapter 6 there, we learned the responding to the environment by human, and then we are responding to the environment, or we need this nervous system, we need this human nervous system, so that we'll be able to react to the stimuli, so that we can able to coordinate the various activity. For you to speak, for you to walk, for you to jump, for you to run, for you to do everything that you are doing, you need this human nervous system. You need these cables that they are sending message to something. You need your brain, you need your spinal cord. There's no way, right? So hence we did this human nervous system, and then from there we wanted to build this chapter coming together with you. So we started you on a basic level, know about the human brain, understand what is happening with your human brain, right? Basic information, basic education. You learn that we have the corpus callosum that is connecting the left and the right hemisphere. Since you know that your brain, it's made out of two hemispheres, the left hemisphere and the right hemisphere. The left one controlling the right side, and then the right side controlling the left side. So if you write using your right hand side, you are using your left hand part of the brain, your left cerebrum, right? So if you are left-handed, it means that the brain that is functioning, it is the right cerebrum, right? So you know that in cerebrum we are thinking, we are doing all those things, here's the higher thought reasoning, you are reasoning here, you are using your memory at a fully capacity, right? We talked about this yesterday when I said I will never expect someone to say use your medulla oblongata for someone to reason. Medulla oblongata, we are controlling breathing, or we are controlling involuntary activities, right? And then cerebrum, there we are coordinate all involuntary muscles to ride the bicycle, to jump, to do everything, the balance there. We are going to talk about this when we talk about our human ear, because our human ear bring the balance to us, right? Where do we find our balance? We find it in our human ear. So we will have another neuron bringing the message to your cerebellum there, right? With your cerebrum, human eye, right? A human eye is bringing the message to the cerebrum there. With our human ear, they have 3 receptors. The one receptor, you learn about this tomorrow, right? Then you learn about this next week. Hypothalamus there. This is the place where we control the hunger, the thirst, the sleep, the body temperature, the emotions. We're now kwatile. Hypothalamus is activated. We learned that, we did the activities, we did the neuron. Even yesterday, I even came and do this small revision here, right? This is the neuron. You know that in a neuron, we will want to see the cell body different with our motor neuron, different with our, this one will be our motor neuron, this one will be our motor neuron, different from our sensory neuron, different from our interneuron, like this, right? So we'll have to see the cell body, we'll have to see the cytoplasm there, right? The space there, cytoplasm. We also have to see the cell membrane. Don't get confused here. Here we have the cell membrane. You might find that there is a here. You see they are pointing at a cell membrane, right? So this, all of it is a cell body. Cell body consists of a nucleus, consists of a cytoplasm, right? And then dendrites there. This dendrites, they transmit impulse toward the cell body, which is the cell body. This is the cell body here, right? And then we have the myelin sheath. You know that this myelin sheath, they are protected by a layer called neurolemma, and then they also have their nucleus there, but we don't have to know about this in our book or in our syllabus, right? But this, in our textbook, we were told that this myelin sheath, they are protected by a layer called neurolemma, and this layer plays a role in our repairing of our myelin sheath if they are dying, right? Or maybe when we see the multiple sclerosis, so that the multiple sclerosis will not be that much affecting us. We see that these myelin sheath of ours, they are protected by a layer called neurilemma, and then we also have the axon transmitting the impulse away from our cell body to our axon terminal. This will be our axon terminal. The axon terminal will have our synaptic nerve, and then this synaptic nerve, it's going to make a synaptic gap with our dendrites of our cell, our next cell. So if this is a motor neuron, if this is the motor neuron, this is what is going to happen. You are going to have those what we call our synaptic knob, and then this will be our tissue, and then this synaptic node, they are going to remove those neurotransmitters, and then this tissue here is going to pick up those neurotransmitters and it's going to react, right? If it's a muscle, the muscle is going to have to receive that electrical impulse. You know that when we talk about the impulses, we talk about the electrical impulses, right? And then we also have to talk about the transmit. Here we have the keywords. Use the keywords transmit, use the keywords impulses. Mind you, during our classes, I even told you that the letter or the meaning or the message, we are going to cancel it. We are no longer going to use a message. We were using the message so that when you'll understand, oh, these things is being passed from one neuron to the central neuron, so that it will have to be interpreted, and what is being interpreted is a message, right? Then that will be our impulse. So you learn this, we learn about the structure, 3 structures or 3 types of our neuron, right? These neurons, our nerve cells. We learn the structure there. This will be our sensory neuron. How do we identify it? The body there, it is protruding outside of our axon, and then this will be our dendrites up until here, because the function of this dendrites is to transmit the impulse to the cell body, and then you also have to indicate that a direction of an impulse there, right? So direction of the impulse is very much important. The cell body, the name of whatever you are drawing. If they ask you to draw a sensory neuron, the name is there. The cell body, we want to see it, maybe 2 definition there. So maybe you'll come and myelinate here or myelinate here, and then we'll give you 1 for sensory neuron, give 1 for cell body, 1 for direction. Is the structure right? Yes, we give another 1. Whatever, if it's out of 5, so we'll need to see another what we call another definition there. Maybe axon, we give you another label there, or another axon terminal there, we give you up until those 5 marks comes to the count, right? But you know, out of that 5, I will have to have 1 here, the name figure here, I will have to have the 1 of here, and I also have the 1 here, the right structure. I will also have the 1 of the direction of impulse, right? And then the 2 will be the 2 labels. I hope you understand that. I hope you are ready to answer those questions. And then from there, we'll have the motor neuron. The motor neuron, you'll see it's going to affect our effector there. Then the direction of impulse, you'll see it from the dendrites or from the cell body to your to the effector there, or to the axon terminal, right? You'll agree with me. And then you are going to myelinate it, and then you're also going to give the axon there, you're going to give the myelin sheath there, so that those marks can make up to that 5 or that 6 or that 7 mark that they are giving you. Remember, always give your drawing or your table the heading. That one, give force, whether you like it or not, whether you are going to draw something that is wrong, name it. This is a motor neuron according to me. Then interneuron, you see with interneuron, it will depend if these are the axons, this will be the dendrites, and this will be the direction of the impulse from the dendrites to the cell body. And the cell body there, you can see it is not protected, or it's not surrounded by our dendrites, not same as our axon there, right? So this one, it is found inside, it is found at a central nervous system, this one here, right? This one, the axon, it is leaving central nervous system, and this one here, this part here will be inside central nervous system, and this part here, it will be outside. You remember, we have our dorsal root there, and then that dorsal root there is housing that cell body. So that cell body there, it will be outside of our central nervous system. So the cell body will be before we can enter our central nervous system. I hope you understand that. I hope we are clear. From there, we did a reflex arc. With our reflex arc, we know that it starts with our receptor, followed by our sensory neuron, followed by our interneuron inside central nervous system, and then followed by our motor neuron, and then followed by our effector, right? Same thing here. We can use any stimuli that we want. We can use a pin, we can use the light, we can use the hammering you here, we can use anything that can exert pain here, right? So since you have the pain receptors here in your thumb, you are going to have something called the pain receptors in your skin. So those pain receptors, they are going to recept your stimulus and convert it into an impulse. Right, after converting into the impulse, your sensory neuron is going to pick up those impulses, or is going to pick up those neural transmitters, and then impulse is going to be passed via the sensory neuron here, carries the impulse to, you can see here they cut it because it's a long process. Right, we did the external, the peripheral nervous system. I even told you, I even showed you the longest neuron in our human body, called a sciatic neuron, right, a sciatic nerve, sorry. And then from there you can see the sensory neuron is passing via our dorsal roots there. Then this dorsal root is housing our cell body, it's a sensory neuron, right. This is how we use to identify which of these two it is a sensory neuron, right. So from there it's going to enter in our interneuron. Where do we find our interneuron? In our spinal cord. We found them at a gray matter, and then at the white matter they are there, or this white matter is going to house the axon that are going to take this neuron here to the brain, right. Then when you're going to be registered that your thumb or your nail or your what or your pinky finger, it is burning inside your brain, right. And then this one here is going to affect your bicep here on your hand, so that you'll be able to pull away the hand before the damage increases, before you can burn your hand going further, right. And you can see those impulses, they will be passed to our interneuron inside our central nervous system. From the interneuron is going to be passed to our motor neuron. The motor neuron is going to pick it there, the body is inside the gray matter, and then the axon is going to pass via the ventral root, and then to our effector. That's what our effector, and then the effector is going to respond to the stimuli. If it's the hand, we are going to pull away, right. And then there's the thing, if this is the leg is going to go up, knee jerk. You know, we talked about the knee jerk. If you hit here, the knee jerk is going to pull the leg up, right. And then this one will be our motor neuron, carries the impulse from the central nervous system to the effector. So that is what is happening. You'll agree with me, right. So we did this activity. Still remember, we came and did our human eye this week. So this week we were dealing with our human eye. Now you know what is happening with our human eye. Just looking at this, you know what is happening, right? And then the most important two things that we have to know with our human eye, that part there, which will be the iris and our lens, our suspensory ligament, our cell body, and our ciliary body and our ciliary muscles, right? Those helping to bring about accommodation and to bring about pupillary mechanism, so that our image can fall right to our fovea there, or our yellow spot there, and then the light there will be dimmed, so that we'll see something in a dim light, and it will be more light, so that we'll see things in a more light. You'll understand, right? So we even did the what we call another one. We even did the disorder, the visual effects here, when our photo is being placed here, or when our photo there is being placed there. You did this yesterday. You'll agree with me, right? This is what I was talking about, the accommodation. We said that for something that is near, we want to see our lens becoming big. Something that is far or a distance, we want to see something that is small. And then yesterday I was talking about the cycle, what chart. That, guys, I was wrong there. The chart that we use the chart that optometrists use, it's called Snellen. I did rectified myself, right? Snellen chart, right? Those chart Z, right? It's called Snellen chart, Z, something like that, right? That is what we call, right? And then we are using this Snellen chart to find something called a visual acuity. So with visual acuity, you know that we calculate our 6 meters, right? This will be our 6 meters. This will be you. Anything behind 6 meters, it will be considered as a distance vision or distance subject. Something that is 6 meters going between your eye and the 6 meters. Here we say this one is our near vision. So you are not being able to see clearly something that is at 6 meters here. We say that your visual acuity, it is 20 out of 20. You'll say this 20 out of 20 or 6 out of 6. This 20 out of 20 is 20 feet out of 20 feet, or here it's 6 meters out of 6 meters. 20 feet is equivalent to 6 meters, right? So we're not being able to see something is here clearly. We say that your vision is 20 out of 20, or we say that your vision, it is 6 out of 6, right? So for you to bring that vision, or for you to understand, or for you to see whatever that is from a near or an object, your eyes have to accommodate for that object, right? We talked about this. Something's near, our lens has to become big, and then what is making our lens to become big? Our suspensory ligament, they're slackening or they're loosening, and then our ciliary body, our ciliary muscles there, they are contracting, and our ciliary body there, it's coming down, right? Or it's coming towards our lens. Same opposite this side, you did this, right? And then we did the pupillary mechanism when we are dealing with the irises there. We talked about this many times. These are made by a radial muscles and a circular muscles, right? We did an example of elastic band. For you to pull the elastic band, you have to contract here and relax that elastic band. But for that elastic band to become small, that elastic band, it has to contract and you have to relax that that radial muscles, right? We talked about this. And then yesterday we're dealing with visual defects. You'll agree with me that in these visual defects of ours, we have the short-sighted that it is corrected by a concave, and we also have the long-sighted that we correct by a convex, because convex, we talked about this yesterday, convex, it bends more light, same as with accommodation, right? Our accommodation, our lens is becoming more convex so that it will bend more light. And then concave here, it bends the light outwards, right? It bends the light outwards like that, right? So but the nature of the defect, this is an inability of or when your eyeball, it is too big. As you can see here, the eyeball is too big and the image there, it is falling in front of that retina, giving our yellow spot more light there, right? So we want the pinpoint, we want to pinpoint it like this, and then we can fix this by wearing a concave, right? Or you might find that your lens there, it has an inability, or it cannot become more flatter. Why are we saying it cannot become more flatter? Because we need it to come down so that it will be more convex and it will bend more light, right? So because it's not bending, yeah, we need it to be more flexor like this, right? The inability of lens to become more flat. Here we have a long, we have the short. This one is, let me see, but the inability of lens to become more flat. So it means that your lens is not becoming more flat. Oh, yeah. Your lens is not becoming more flat. Why? Yeah, Mr. Mpepu, your lens is not becoming more flat because when it is flat there, it has to accommodate something that is far, right? So when you are pushing something closer to you, then your ability like this, your lens doesn't have an ability like this, inability for lens to become more flat, right? To stretch so that it will push, so that it will push this here backwards, right? So hence we use a convert so that we can help it to push that away, right? As different here with our long sightedness, when things are placed there back, it means that your lens there, it is more, or inability of your lens to become more convex. You have inability of this to come back, right? To accommodate something that is near here, right? And then for here, you are short-sighted, you cannot see something that is further away, so your lens cannot do this with our accommodation knowledge, right? You'll agree with me with the accommodation knowledge. We are passing by here, and then by the correction, you just have to wear the bi-convex. Take Magogolo's I2 again. This Magogolo's I2. These are the bi-convex, two of them, right? Then if you want, we call it a convex, right? And then there's a name there, we call it a myopia or hyperopia. Myopia, short, and then hypermopia. Hyper means more, it means that you are further away, right? We say the long-sighted or the distant-sighted, short-sighted, near-sighted, something like that, right? Or we might have the lens bends and the light rays too much, right? These are lens are more lighting too much. It means that your lens here is becoming big always like this. Even if you are moving something away, it is always big. It is always caving these lights here at before our retina, right? And then as a result, the image here, it falls in front of retina. This will be the results, causing the image to be blurred because more light there will be passed, right? Cannot see distance object. You cannot see distance object because when we are moving away the distance object, your lens cannot stretch like that, right? And then with long-sighted, we did all of this, and then the lens does not bend light rays enough, right? So you have inability of your lens to do this, right? As a result, it falls behind the retina, but causing the image of the blade, and then cannot what. So your lens here stays like that. Your lens here stays like this, right? You know what? For lens to be like this, our suspensory ligament, they have to be tightened, and then our ciliary body there, it has to push away from our lens, and then our ciliary muscles, they have to relax. You'll understand, you'll agree with me, right? As a result, it falls behind and then causing the image to be blurred because now our retina there, it is the light that is focused at the retina there, it is still open, right? Right? And then they say the eyeball can be shorter there. The eyeball can be shorter, pushing away And then to correct this, we can use our biconvex magugulus I2 that are biconvex, that are shaping outside like that, right? And then the name there is called hyperopia. Then we have astigmatism and cataracts. Astigmatism is when we have an uneven lens and our cornea, but cornea there and the lens there. And then the glasses with a lens correction could be distorted. Here we want to prescribe a certain glasses that they can distort that image, so that they can fix, right? If you are saying that your cornea or your lens is bent inside, we talked about this yesterday. If you're saying that your lens is not bending inside, we will need a convex or we need a concave, right? And then cataract there, these are the lens becoming cloudy. And then the plaque here, I told you this one is at the clamps, right? The clamps, protein plaque, things making a clamp, right? And then the surgery can be suggested to this person so that they would remove replace the length with synthetic, right? Or we call them synthetic or artificial, right? Man-made lens, right? So that was it, guys. Today's we are dealing with our activity. Let's do this activity in less than 20 minutes and then we are done here, right? We are done. Thank you. We're going to meet next week under the human eye, under the human ear, and then from there we are going to move to endocrine. You'll agree with me, right? Thank you for being here. Activity 3, fast. We did this. We are just passing by here. But question 1, let's start here. But figure 6.3, this is 6.13, shows a longitudinal section. You see, we have a longitudinal section and we have a transverse section. A longitudinal section, it's when we have something and then we are cutting it like that. And then transverse section, it's when we are cutting like this. You learn this when we move on, right? A longitudinal section through the human eye. This is the longitudinal section through the human eye. But study the diagram and answer the question that follow. When we come and study the diagram, you can see that the diagram, it has many points, right? Many labels. Number 3, this one will be the length. And then number 4, suspensory ligament. Number 5, ciliary body, ciliary muscles, pupil, and a cornea, right? So you can see there, you can also see that we have 2 lines. Then this line here, it will be our conjunctiva if they want us to talk about that. But since you can see that it's not here on our book, they are not going to talk about that. The line that will be here, it will be a continuation of our sclera making our cornea, right? But number A, label part 2, 3, 4, 5 respectively. When they say respectively, they want you to come and say number A and then say number 2, 3, 4, 5, 1 individually. So because when now you can just come here and say a part number 2, number 3, number 4, number 5, these are the parts of a human eye. Yes, they're the parts of the human eye, but we want you to label them. Give us the name respectively. Number 1 there, it will be our cornea, right? Cornea. And then number 3 there, it will be our lens. Then number 4 there, it will be our suspensory ligaments, right? And then number 5 there will be ciliary body. Don't forget and don't make sure that you see where the point is pointing, because there's a ciliary body there and the ciliary muscle, right? So then 2 should be differentiated accordingly. Name and describe the process that causes part 1 to dilate. Where is part 1? This is part 1. Name, they want the name and also describe. You're going to say number B, give us the name. The name will be pupillary mechanism, or pupillary reflex, or pupillary constriction, right? And then describe it now. We want to describe the process that causes the part 1 to dilate. So you come and write this, you'll come and write this, and after that you are going to write something like, okay, you're going to cite a dim light, right? Because we want to see our pupil there, it dilates. To dilate is to become big, right? We talked about this terminology. To dilate is to become big, or wide. They also gave you the explanation here. Becomes wider, right? Then we will say dim light, and then in a dim light you are going to talk about, you can say it's 5 marks, right? 5 marks, sorry, it's 5 marks there, and then this 5 marks, 1 for the naming the process, and then 4 for naming here, right? So you want to talk about those iris muscles. Then you'll say you'll have 2. You will have the circular muscles, and you also have what? The radial muscles, right? So you see it's opening for me to open this, the circular muscles, they have to relax. And for me to pull this away, the radial muscles, they have to contract. 5 months. 1, yeah, the name. 2, yeah, circular muscle. 3, 4, 5. Utswakayo. Right? What more do you want to say? Because the pupil is being controlled by our iris. And the iris, it only have 2. Here, they will also give the circular muscles of iris. Yeah, you have to say this. Can relax. And the radial muscles of iris. Because if you just say radial muscles contract, radial muscles where? In your human body, you have many radial muscles. So when they are contracting, are you saying that you understand? So you have to say radial muscle of iris. They will contract. And then the circular muscles of iris, they will relax. So forth and so forth, right? So these two, make sure the name, describe, give the name, and then start to describe, right? And then number 2, but number 2, 6. We are done with that one. 6.14, we are coming here. This is the longitudinal section of a human eye. You can see, right? They cut it straight. This is a human eye, cut it like that, right? And then, when you are viewing it this side, they cut it like this, and then when you are viewing it like so, right? And then this is called a longitudinal section. Many things, they come with longitudinal section, right? You can cut a I was thinking about something. Let's not talk about it. Through the human eye, right? The structures which enable the eye to focus on objects are missing in this diagram. We know what is missing. Before, we can also know that these are the parts that enable the eye to focus to an object. They are talking about that lens there. Then they are talking about that suspensory ligament there. They are talking about that body there. We are talking about that body there. We are talking about that muscles there. We are talking about that body there, right? Also the iris and also the iris. This is what is missing, right? Barry, study the diagram and answer the question that follows. Barry, draw a longitudinal section. Draw something like this, longitudinal, something like this, right? Draw a longitudinal section through the missing parts of the figure 6.0 to indicate the appearance of this structure when you are reading a book. When you are reading the book, something, it is pushed closer, so we are going to see our pupil becoming big, right? So we want to draw this when our iris, when our lens, accommodation, we are dealing with our lens. So the lens here has to become big, or it has to become bulgy. If we are going to cut it like that, it has to become bulgy. So when you are going to draw, they want to draw it, they want to sketch it, right? Sketch it somewhere. You don't sketch everything, you just come here and sketch it outside of here, right? So now I'm going to sketch it here, or let's just sketch it outside. You're just going to say number A, reading book, and then you want to draw your lens being big there. And then from there, this is not, you also have to include those ciliary suspensory ligament, suspensory ligament, for you to understand that this suspensory ligament of yours to become slackened or to become loosened like this, your ciliary body has to come towards, and the ciliary body here has to come towards. And then for this to come down, our ciliary muscles, they have to contract, our ciliary muscles, they have to contract, right? And then from there, you write a longitudinal section. You write a longitudinal section of what. Here we are going to write this, a longitudinal section of the part, or you are just going to write accommodation, right? Yeah, simple. Accommodation, you can write accommodation of a closer subject, right? And then there you're going to what we call to label this. Here we are having more convex lens, right? Or bigger lens, right? And then here we are going to have slacken or loosen suspensory ligament, right? And then here we are going to have a ciliary body towards the lens. Here we are going to have ciliary muscles contract, something like that, right? So you can see it's out of 6 marks there. We are going to give you the name, right? The structure, did you draw? For the reading book, your lens, is it big? Something is this the correct structure? Yes. 2. We have 2. Then we want to come to 3 lens, 4 suspensory, 5 ciliary body, 6 ciliary muscles, right? And then by number B, looking at an object more than 6 meters away. So you know this one, you have this 6, and you are also coming to take this 6 because you are only going to draw the opposite of this. Then the opposite of this is going to be number B. Then number B, you are going to see right? And then for this to happen, you know that our ciliary body has to stretch. Our ciliary body has to stretch. For our ciliary body to stretch, our suspensory ligament, don't make mistakes like I'm doing. Suspensory ligaments, they have to stretch, and then while these suspensory ligaments are stretching, our ciliary muscles there, they have to relax, right? You have to write, then you'll write it. This is what I was avoiding. Then you'll write it here, lengths, right? Flatter lengths, or lengths less convex, however you want to write it. And then here you write suspensory ligament tightened, right, or taut. Then from there you're going to write your ciliary body away, from the lengths. And then you are also to give us that our ciliary muscles there, they have relaxed. You'll agree with me, right? So those 6 marks there, you get them. So let's go to our memorandum and see our memorandum. Cornea, right? Lengths there, we were defining that suspensory ligament there. We were dealing with this, right? I'm seeing my heart there is broken. What is happening here? Browser essential. Now it's right. And then ciliary muscles, right, or ciliary body. Well, now you have to write cilia. That was a ciliary body, not a ciliary muscles, right? We can correct this book here. This one, number 5, is a ciliary body there, not ciliary muscles. Then number B, the mechanism is called pupillary mechanism, or pupillary reflex, or pupillary constriction, right? Constriction, right? That way you're going to get that one of yours. Then we want to get with that 4 radial muscles of iris. We give you here. We don't give you here. We are going to give you here. The radial muscles of iris, yes. They are going to do what? They are going to contract, yes. And the circular muscles of iris, yes. They are going to do what? They are going to relax, yes. And then the pupil dilates, more light enters. This one, I'm not sure if they will give you, because they just want you to, they told us that our pupillary muscles, they are dilating, right? Or you can say more light enters. Since you write the dim light, with a dim light, you want more light to enter, right? They can give you that 1, 5 there, but they will first by giving you 1, 2, 1, 2, 1, 2. So from there, we were drawing here, we were drawing accommodation, and here we were drawing an accommodation. They said this one is an accommodation because it is not accommodating. Here, everything is relaxing, right? Here, you need energy, because your suspensory muscles there, they have to contract. You know that for muscles to contract, you need energy. Hence, we say this one, you are accommodating, right? And then when something is moving away, you are unaccommodating. Your length is unaccommodated. Your length is just staying as is. So this one, our suspensory, these are going to relax. Our suspensory ligaments there, they are going to tighten up. Our length there is going to be convex, less convex, or flatter. And then our suspensory ligament, we talked about this, they are going to be tightened, or they become to be taut. This side, our suspensory ligament there, both sides, right, they are going to be slackened or loosened, and then that cause our lengths there to become big or to become more convex. And then ciliary muscles there contracting, bringing our ciliary body towards our lengths, right? Next week, human ear. How are you hearing me? And how do you hear me? You see? And then, mind you, another thing, our human eye is taking these neurons to our brain, and when they enter our brain, they are going to be stored, right? And then even our voices, or even our whatever we are going to be hearing, is going to be sent to our cerebrum, and when it enters our cerebrum, it's going to be stored. Same as those who are following me yesterday. Now you can place your phone away and you can tell the person who's speaking here, give me Mr. Pape, because my voice has already registered in your brain. Even with our picture, because you don't know me, the first time you see me, it will be the first time. Your brain will be registering me for the first time. But when you see me tomorrow, you'll be like, that person, I know him, give me Mr. Pape, because the message now is stored inside your brain, and then you can just go and take it out. I hope you understand that. And then with our human ears, now we better amapiano. Then you understand mo ke touch ya kabza the small mo, or mo ke mang mang mo, or someone is just talking je. Then you can tell this person is mang mang by just hearing whatever they are saying. So we are going to say, or tomorrow we are also going to learn, next week we are also going to learn about the neurons or the receptors that they are recepting sound, right? After recepting sound, turning it into the stimuli, and then turning that sound stimuli into our impulse, and then that impulse being transmitted via a nerve. In our human eye, we call this nerve optic nerve, right? And then in our human ear, we name this a nerve or auditory nerve, right? From the auditory, from auditorium, right? Audio nerve. So now we are dealing with our nerve. It's a connector, the speaker, sort of like mic and the speaker. You use your mic, hello, 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 1 2 1 2. Then the speaker there release the sound, right? So now we have the speakers. You learn about this, also complicated structure, but if we learn it, how they plan us to learn this in a whole week, I'll tell you that by the end of the next week, you will be able to interpret and know what is happening with our human ear. We start with the structure. After structure, we start with the process that is happening. You know, with our human eye, we started with the structure. From the structure, we learned the accommodation. Those are the things that are happening with our human eye. Then with our human ear, we are going to learn about the hearing. How do you hear? And we're also going to learn about what we call another one, balance, right? From there, Wednesday, question and answer. Thursday, we are going to learn about the defects. Friday, revision. Sibonge, danko. That was it from me, Mr. Mpepu. Okay. I promised you, or I also asked you to go and do activity 7, right? So let's do this activity 7 in less than minutes, because we are done, macabang. Read the extract below and answer the questions that follow. Kayise, age 60, right? Okay, we start by the reading, right? Kayise, age 60, had failed her vision test for the driver's license. All her life, she had suffered from extreme nearsightedness. In fact, without her glasses, she was legally blind. When she was denied her license renewal, Kayise came to Dr. Nobadula. Kayise came to Dr. Nobadula for help. During an examination, it became clear that Kayise had cataracts in both eyes. A cataract is a clouding of the lens in the eye, which reduces vision. The lens is inside the eye and focuses the light into the retina of the back of the eye, where an image is recorded. The lens also adjusts the eye's focus. The lens is made of mainly water and protein. The latter is arranged so the lens stays clear, allowing light to pass through it. Yet with age, the protein may form clumps that cloud the lens. This is cataract. The best solution for Kayise's solution was surgery that removed the cataracts and implanted tiny artificial lens within the eye. Dr. Nobadula conducted this procedure. Today, for the first time in her life, Kayise enjoys 20/20 vision without glasses. Right? We talked about this. What is 20/20 vision? 20 feet out of 20 feet, right? 20 feet over 20 feet. So it means that something that is at 20 feet, you can see it very, very clear. We say that people are average, right? When you say you are average, you are able to see 20 feet, 6 meters. Same thing, right? Then here it will be 6 out of 6. So let's come to our question and read. We understood there. If you don't understood, go and reread it, right? And then, number 1, but describe what is meant by nearsightedness. What is meant? Can you do too, since it's Friday? Friday malamulele. So today's Friday, guys. Tomorrow is Freedom Day. What will you be doing tomorrow, Freedom Day, guys? Talk to me. What is it that you'll be doing tomorrow, Freedom Day? Where are you going to celebrate Freedom Day? Are you going to be watching Sarafina? Sarafina, you are the one. So let's go, guys, and celebrate the freedom. Our forefathers or our ancestors died fighting for this freedom, my friends. 1976, slavery, mang. And then today we are dealing with freedom. If I still remember, there was an advert in a TV where they were asking, are you free or are you dumb? Right? Freedom. These are the dumb cops that are free. I'm not sure. Hey, let's not go there. Let's not go there. Hi, let's not go. Highway to Nana. Freedom. Dumb cop, you are dumb that is free. I'm not sure. Hey, a freedom means free. We are free. Economic freedom fighters, freedom on our lifetime. Let's be free. Even if we are dumb, but let's be free. Let be dumbs that are free. Hence today we have rights for everything. I have rights for anything. Rights for life, freedom of speech. Because of this freedom, I'm dumb that is free and that can say whatever they want to say because they are free. So aluta continua. Struggles continues, guys. Number 1, activity 7, number 1. But describe what is meant by nearsightedness. What can you say when you say someone is nearsightedness? Nearsightedness, short sight. You see, nearsightedness, short sightedness, closer sightedness. What is it? But in nearsightedness, we can say this is an ability, right? Or it is when the person is able. We can write it down. Let me say it better. This is when the person is able to see, right? This is an ability when a person, you are going to do like this, nearsightedness. Then you try to explain this. This is the condition, or this is the ability where the person is able to see a near object, but cannot see the distant object clearly. You have to write that clearly. Or if you don't want to use that, you can say this is the condition, or this is an ability of a person to focus on a near object and they focus, or they cannot focus on a further object, right? So name the two. If you are using to see, also classify that to see clearly, right? Because the person is not totally blind. They can see, it's just that they cannot see clearly. So let's write it down. You'll come and say near. I don't like it, the pen like this. You are going to say near sighted. Near sightedness, right? Let's talk about what is this. This is the ability, or when the person is able, I'll write this, the person is able to see, right? The person is able to see what? A near object, right? From the near there, a near objects, but cannot see objects more than 20 feet or more than 6 meters. Here we use meters in South Africa, right? Meters away. Then we have to write clearly there, because if we don't write clearly, it will be like the person cannot see, right? The person can see, but we want the person to see clearly. Then the nearsighted, the person is able to see near objects, but that one will be right. The person will be able to see a near object, but cannot see the object more than 6 meters away clearly. That will be another right. 2 marks there, right? Anyhow you want to kill this cat, make sure that the cat is killed. When I say that the person can concentrate on a near object but cannot focus on an object that is more than 6 meters away from that person, right? Number 2, number 2, which type of lens can be used to correct this defect? We talked about this near, cave, feather, vex, right? Here we'll say concave what? Concave lenses. You're not just concave. Concave what? They want the lens. We want the concave lenses, right? Can be both if there's 2 eyes, or can be one if that person is, we are correcting 1 eye, right? Number 3, what causes the clouding to form in the lens? What causes the clouding? This will be the protein, right? This will be the proteins. Yes, proteins, right? Where? We can say proteins found, because they are there, right? Protein found in the lens, because the lens is made out, they told us somewhere that the lens is made out of a protein and water, right? Where the lens also adjusts the letter, yeah, water and protein. So these proteins inside the lens, they cause this clouding, right? You'll agree with me, right? Number 4, or what causes the clouding? These are the proteins found in the lens. They are doing what? That clumps, right? Or that forms clumps, whatever. We can just write that list. Proteins found in the lens that clumps or that form clumps, right? It means that those proteins, they are coming together, and while they are coming together, they are causing this clouding, right? For us to see this clouding is because this protein found in the lens, they are clumping. Yeah, that one will be correct. One mark either way. Number 4, in your opinion, kamunahano wa hao, kangqondo ya hao, what could happen to Khanyise if she did not have the surgery? 1 mark, right? They want your opinion, but here's the trick in these questions. They want your opinion that can be anyone's opinion, right? Because in your opinion, they can ask you, in your opinion, what could happen to Khanyise if she did not have surgery? You can say she was going to die with her natural length, right? That was your opinion, but that one is not going to help here, because the opinion that they need here is everyone's opinion, and then in everyone's opinion, she was going to go blind, right? She was going to end up being blind, since we are studying with cataracts, and this cataract, they end up causing someone to become blind, right? So if she didn't went for a surgery, she was going to end up being blind, right? So we can just write she would eventually become what? Blind, or to become totally blind, right? Number 5, Friday, she would eventually become totally blind, or she would, because we are what could, right? What could happen, right? So she could. We were not sure. We are just thinking that maybe she was, but if maybe the cataracts, they did not develop further, she was going to be fine with a blurred images, not blind. Number 5, explain the cause of Khanyise's nearsightedness and sightedness, and why she did not need glasses for after surgery, right? So you need 4 marks. 2. You want to explain why she was nearsighted, and also why she did not need glasses after surgery. She did not need glasses after surgery because her lens was fixed, right? After removing the lens and place another lens, she was not you'll say that, right? And then this was caused by a lens that they cannot adjust adequately, right? It was caused by the lens, right? It was caused by the lens that cannot adjust, right? That cannot adjust, we said adequately, right? To focus for the incoming light, we say it was caused by the lens that cannot adjust adequately, right? For us, when we said we want the lens to adjust, nearsightedness, we know that when we are moving something away, this lens here, they have to adjust like this, right? So because our lens, they were not adjusting adequately due to protein, right? Due to protein's clumps, rhymes resulting in whatever. We're just increasing the answer there, right? Due to that, and it was caused by the lens that cannot adjust adequately due to protein clumps, right? Or due to protein clouding, right? And then during surgery, the thing was removed. During surgery, the thing that was there, it was not removed. Here you are going to get 2 of, because these proteins, this protein were causing our lens not to adjust adequately, or to adjust more, or to adjust in a proper way, right? Or to flatten, or it was caused by the lens that cannot flatten, less convex, whatever, due to proteins there. Because we have protein inside, these proteins, they are causing our lens not to adjust, right? But during surgery, the lens were removed with the artificial one, right? And then with the length removed, then with the length removed, with the length removed and replaced, right? Where were we? This was yesterday. Heaven. What happened? Come on. Heaven. Dinsa, what happened? Heaven. This was yesterday, Musi. Something happened, guys. We'll just continue wherever we are. Something happened. I'll rewatch the video and see what happened. Kotile somewhere, and that board that I was using vanished, right? Because this is what I was writing. This is what we were doing yesterday. This year. Or maybe no more. Nowhere to be found. Let's move on. Number 5, number 6, right? We are done with number 5. Number 2. Number 6, but describe what happens to light rays in the eye of a person with cataracts, right? 3 marks. Describe what happens. Well, now you just have to explain that the light is not entering well, and then from the light not entering well, the light is not refracted well. With the light not refracted well, the person will end up seeing the blurry image, right? The light rays enter through the cornea, yes, but that light is not be able to refracted through the lens correctly, right? The clouding prevents the refraction of light, and the light rays are not focused on the yellow spot, which leads to blurry vision. Everybody describe what happens to light rays in the eye of a person with cataracts. My time is up, guys. I cannot write everything. The light, yes, the light rays pass, right? The light rays will enter the cornea, right? Then from there, while the eye light enter the cornea, the lens will not be able to refract light, right? Or transmit. Do we transmit? We refract, man. We refract and we transmit. Agree. If it's cloudy, it means that the light will eventually be blocked, right? The light rays enters the cornea, and the light will not be able to refract the light to the yellow spot. That resulting in blurred vision, either way, right? Or you want to explain that the light will enter the cornea, but the lens here will be blocked, right? Blocked by what? By our cataracts, and then this will end up preventing light to pass our lens, that resulting in our blind. This one will result in blind, right? This one will result into blurred vision, and if you take it another way, it will result in blindness, right? 7, either way. Name one other visual defects not mentioned in the extract above. We have astigmatism, and what another one? Long sightedness, right? So that that was it from me, Mr. People. Thank you, guys. Meet me next week, right? Next week, when we're doing a structure of a human ear, right? Thank you for being here. Where are we? We are here. Next week we are here, right? Learning how our light is going to be. Let's do this fast. Our wave sound, right? We talk about the wave sound, katla. You know that the wave I have to travel like this, right? This wave, they're going to travel inside our auditory canal, and then it's going to vibrate here, our eardrum. After vibrating our eardrum, it's going to force our hammer there to vibrate. Our hammer there is going to force our anvil there to vibrate. Our anvil is going to cause our stir up there to vibrate. While this stir up there vibrate, we found that we have the liquid here. That liquid is going to vibrate. While the liquid is vibrating, is going to vibrate something inside the cornea, which will be our sound receptors. And those sound receptors, they are going to stimulate that. They are going to convert the sound stimuli into impulse, and then that impulse is going to be passed via the auditory nerve to our cerebra. Next week. Thank you for being here. Thank you for tuning here. You could have been doing something else. Let me leave you with the quote Yan Tate Mandela. Tate Mandela ari, education is the most powerful weapon which you can use to change the world, guys. As we are celebrating the Freedom Day here tomorrow, let me write this down fast. But education is the most powerful weapon which you can use to change the world. That's okay. Powerful. Right? That's it. From Mr. Mandela. Already. Thank you. Let's meet tomorrow, guys. Let's meet next week. Right? Next week, Monday. Human ear. We are done with the structure of human eye. Today, goodbye. Thank you for being here. Thank you for tuning in. Thank you for subscribing, guys. Thank you for liking. Thank you for commenting. Thank you for sharing these videos of mine, guys. I really like to appreciate you. Until we meet next week. My name is Mr. Mpepu. Let's learn life science with Mr. Mpepu. Until we meet again, peace. Khutsonga belilina mulalo kwa bena batho bote, kurula ko benani, ukuthula ko benani, all over South Africa, all over Africa. Until we meet again, happy Freedom Day in advance. Viva Africa. Viva umntu mnyama phupuka. This is the education that we can use to change the world. Let's share this education together. Subscribe. Until we meet again,